Okay, so I think everyone it's already in. So good morning, everyone, and welcome to today's workshop towards a digital-powered green transition, scaling innovation and connectivity in energy services. Thank you very much for joining us today. My name is Raquel Castan, Communication Manager of ODEON Project, and together with Lukasin Osik, we will co-moderate today's online workshop. This event is jointly organized by Horizon Europe Projects, ODEON, and HEDGE-IoT, and with the participation of other projects, TwinEU and INSIEME. All these projects are funded by the European Commission under the Horizon Europe program. And today's session will last around 1 hour and a half, so welcome everyone. So during this workshop, we will explore how digital technologies can support the green energy transition in Europe. We will discuss topics such as artificial intelligence enabled energy services, interoperable digital platforms, secure and trusted data sharing, and challenges of connecting energy services across multiple stakeholders. The goal of today's session is to exchange ideas, share experiences, and promote collaboration between projects working on Europe's future energy ecosystem. We are very happy to have you with us today. So before we begin, let me briefly guide you through today's agenda. We will start with an introduction from the representative of DG Connect at the European Commission, Mr. Svetoslav, followed by a live poll to get know our audience a little better. Then we will continue with 4 project presentations, INSIEME, ODEON, TwinEU, and HEDGE-IoT. So please note that you can submit your questions in the chat throughout the presentations, and we will address them during the panel discussion. Following the presentations, we will transition into a moderate panel discussion with 4 speakers, with our speakers, and we will dive deeper into these topics and answer your questions. So as we mentioned, today we are joined by representatives from 4 Horizon Europe projects. Representing the organizers of the event, we have Moises Anton from ODEON Project, and also Nikolaos Bilidis from HEDGE-IoT. And also representing the guest projects, we have also Ilias Safeiropoulos from TwinEU and Georg Hartness from INSIEME. So thank you very much for participating in this project. So now we are very pleased to welcome Mr. Svetoslav, Policy Officer of DG Connect at the European Commission. Thank you very much for joining us today. Svet, the floor is yours.
Yes, thank you. Good morning. Indeed, I'm very glad that I have the opportunity to speak at this event. And as somebody personally involved from the Commission side in all these projects, I'm probably the best one to explain the vision of the Commission in this respect and how these projects fit and how this gathering of the projects and common work of the projects also fit into our vision and ambitions. So first of all, of course, always to say that we have our big guidelines within which we work and that are defining our directions and our actions, initiatives. So of course, here we're talking on one side for greening. So there we have the big rock, which is the European Green Deal. And under it, the different initiatives, which I'm not going to list, but things like Fit for 55 and all the others that are defining targets in environmental and energy targets. Then we have also, of course, digital targets, digitalization as a topic, and then we have Europe Fit for a Digital Age, and under it, again, different initiatives like the European Strategy for Data, which evolved into a data union strategy recently, Then we have some legislation, the Data Act, and other Data Governance Act, Markets Act, etc., different acts. I'm going to go into the other topic of today, AI. But before, just to mention that also the two, energy and digital, meet in several of our communications that we have sent out and strategies and initiatives. Of course, one was the digitalization of energy action plan. And another one is in the preparation now, it's the strategic roadmap for digitalization and AI in the energy sector. So they're working together to define how digital and AI will be used in the energy sector. And then if we look at on the side of AI, we have a number of initiatives, legislations, and actions. So already last year, we started the initiative, overarching initiative of the AI continent, which includes the so-called AI factories and AI gigafactories. So the idea is to build AI capacity at scale in Europe, which will provide compute, data, and tools to innovators. And then again, it's one of the topics today, the innovators. And then, of course, the idea is to reduce our dependence on non-EU infrastructure. I mean, it's not a secret that the biggest players, even in Europe nowadays, are the American hyperscalers. So this is, of course, not a very comfortable situation to be with for us and for our sovereignty. Then, again, last year, we started the Apply AI strategy. This is a bit different from the previous one that I described. It falls within it, within the AI continent, but so it is about deploying AI to the different sectors, have it perform in real sectors, in real life, in real workloads. And we have piloted stuff, we're still piloting, but it is to have real deployments in commercial environment. And then, of course, the idea is that this boosts productivity in these key sectors. So not just to implement it, but to have real value in these sectors. And then, of course, to support innovators such as SMEs and other startups and public service, etc., within this sector. And then here, of course, the strategic roadmap for AI and digitalization in the energy sector also follows and supports, works together with the Apply AI strategy. And then this year we had the Cloud and AI Development Act, which is about scaling up cloud and data centers in Europe, again, providing capacity. It should be sustainable and secure and enable AI deployments at scale. So similar thing. We shouldn't forget, of course, to always say that when we talk about digitalization and AI and energy, there are the two flows between them. So energy powers AI and digitalization, and digitalization AI supports the energy system by optimizing it, by providing computing power, connectivity, etc. That allows it to deal with the increased complexity nowadays with all these distributed systems everywhere, prosumers, renewables, storage, you name it. It's a completely different system which cannot be managed the old ways. And of course, when I mentioned renewables and so on, we should remember that the goals is when we're doing all these things within the energy system and using utilization is to achieve decarbonization, to manage the decentralization, to increase utilization, etc. And of course, there are already results to some extent. We have been doing this for years, not necessarily in the most modern ways now with AI, but it was available before. But of course, it needs to go a lot further. And that's why we're pushing with new initiatives, etc. It is also to lower energy costs, both for businesses in order to stay competitive and for the consumers. So it's not to squeeze their purchasing power and their wallets. Reduce emissions, so be able to integrate more renewables and to use more efficiently and more of their available capacity, because we know that even now we have enough capacity renewables in order to power the whole system, but we cannot because it's curtailed, it's lost somewhere else. this will help it to optimize it further. And then we have, of course, the new thing of EVs coming, which is a massive consumer and a massive storage and a massive flexibility possibility, etc. But the network and the digital overlay on it need to be able to handle this. It's not just so simple to plug in. It's not like having two nuclear stations that you have to manage sending energy to an endpoint. And we want to empower consumers to use all these things. So within their home, to have an energy management, to use their vehicle as a flexible thing, edge point with the grid and the energy system, to have some tools to manage their efficiency and cost savings. And for all this that I described, we have had all these projects that you are representing here, are going to be presenting, and they're forming different aspects of this future energy system. And we said we want to put them all together. They need to work together. So we have ODEON and HEDGE-IoT, which are dealing with distributed energy system, using AI for this, or AI at the edge and machine learning and so on. So that's one aspect. And we have the TwinEU, which has the digital twin of the energy system, the European energy system. And then we also have the data space, which allows to exchange data between any 2 points within the energy system. So sometimes it will be connecting within this energy system, sometimes it will be between two endpoints, etc. So that's why we're talking this combined system together with AI, also with it, the possibility to use AI services, generative AI services, and so any new AI that is coming. And this we call the so-called digital backbone or spine. I mean, we had to choose some name in order to represent what it is. And it really needs to advance to this kind of overlay digital system, combining all these components that I just mentioned. It can't do without any of them. They're all needed, they're all combined, and we have developed them within this projects that are talking today for 4 years now. They just have to mature into this common layer. And it's not possible to continue the old way, some hard-coded SCADA system in the grid and then some other system somewhere else. No, it needs to be a completely overlay digital system based on digital principles, very flexible, to be able to connect all these endpoints. It's not about only grid and operators necessarily, etc. The flows will be in all directions. So when you have a prosumer to prosumer, it's another flow that doesn't exist today at all. Not to mention that even prosumer to grid is not that widely deployed, etc. So all this is increased complexity that requires a new approach. But we have all the ingredients, all the building blocks. There's nothing so new. What is new a bit is, of course, AI, and especially the generative AI that needs to develop further. But the majority of the rest we have. And then, as you know, or for the ones that don't know, the Commission is committed to this vision, to this approach. So, of course, for this, we have calls and upcoming projects in the pipeline. So there is a call for this first stage of digital backbone, combining all these things and working together with them, because you see the projects are still ongoing, which is under evaluation and to start soon. And then there will be, again, without commitment at this stage, because the Commission cannot commit before it's published. But in the pipeline, there are 2 more calls for proposals or projects on the same topic. So building up on this and further, and of course, building up on some other initiatives like what we had in the Connected Europe facility, the operational digital platforms, which is essentially as well part of this digital backbone. It's kind of represented digital backbone as well. So that was a bit my introduction. Thank you for the opportunity, and I hope to have that you're going to have a good workshop, and I'll try to follow as much as possible.
Thank you very much, Mr. Svetoslav, for this insightful welcome introduction. actually, it's very interesting to hear the European Commission's perspective on these challenges and opportunities. And EIA certainly appears to be the start of the show in the energy digitalization today. Even so, we cannot leave anyone behind. So now, before starting, let's take a few minutes to get know to each other a little better. So please scan this QR code on the screen and join our live pool. It will only take a few minutes. So let's start with some questions. Give you some minutes, but even though you can find here the code again. Okay, so which sector do you represent? Okay, most of you from the energy sector, resource mainly. Let's wait a minute. Okay, I think most of you are from the energy sector and distributor operators, or research, also innovation. Okay, interesting mix of participants today. Also administration, digital transformation. Okay, so I go to second one. So what do you see as the key digital enabler of the green energy transition? Okay, unexpected, artificial intelligence. Okay, interoperability, standardization. Okay, so mainly standardization, interoperability, and also collaboration are the key digital enablers in green energy transition. So next question. So what is the main barrier to scaling energy innovation in Europe?
O si le pasa mucho menú, o si ya no tiene que decir nada y se le pone menú. Y si quiere, pobrecito. Es que de 30 minutos que somos, solo hay uno. Y nada, si le quieres ir diciendo que somos 32.
Okay, so maybe
igual esta persona se ha unido, pero no creo que
again
pase nada, porque venga,
well, regulation, coordination, sandboxes.
O sea, porque ponen en ese individual y sigue individual.
No, sí.
No, ya, las mesas.
Okay, so let's go for the last one here. So what is the biggest challenge in connecting energy data across multiple stakeholders? Okay, interoperability, definitely recurring a theme today. Standards also. Okay, standards, interoperability. Okay, so very interesting results for this short live poll. So welcome back to the presentation. Thank you very much for your participation. So now let's officially begin today's session. So we will start with the INSIEME project presentation by Georg Partner. Georg, the floor is yours. Welcome and thank you.
Thank you, Raquel. And I don't want to be impolite. Yeah, okay. If you could mute yourself, that would be good because then, yeah. Okay, so do you want me to show my own slides or are you showing them, the ones that I sent you?
Raquel, can you share the slides, please?
Okay, very good. Thank you. About the INSIEME project, just briefly, as you know, the European Commission in their strategy for data in 2020 have decided, recommended building data spaces for 14 critical sectors: health, manufacturing, agriculture, finance, mobility, defense recently, cultural heritage, and energy. And for us, so what does that mean? It was defined in very high-level terms. It's basically about organizing, creating common rules at a European level for how to exchange data in which sectors to allow for an EU digital single market and data-driven economies in these sectors. Next. So in that sense, you need to understand that we're operating in the project INSIEME. Project is, we do the coordination through University of Applied Sciences, Upper Austria. The project started in 2025. It will end in March 2028. And what INSIEME aims to do is to create a data space by the sector for the sector. So adopting all the research that has been done on data spaces, but also as the dust has cleared up into what we need in terms of flexibilization, allowing for citizen energy, allowing for sharing of energy, and tackling the critical topics that we see in that transition towards a volatile system, and do a data space by the sector for the sector. So no theoretical a data space for a data space sake, but a data space that helps, that is a means to an end to solve the data integration problems that we see. We are representing 54 partners from 15 member states, have a budget of 16 million euros, out of which 8 million come from the Digital Europe program. And we run more than 14 deployments in more than 16 European countries. Next. Inside this strategy for data, it's really remarkable to see how developments materialize. So if you think back to 2020, when the Commission envisioned the operationalization of a common European energy data space by 2030, they said, okay, from 2022 to 2025, there is the design and evaluation of critical data space components represented by projects like OneNet, EnerShare, DataSeller, Omega X, and Synergies, and also EDI, which was also where we also played a very strong part. Then, from 2025 to 2028, there's the INSIEME project for the deployment and the final pilots for the seeds. So we are digesting all the learnings from the previous projects and organize them into a data space operation model that allows for an EU digital single market for energy. Next. And with our project, we accompany key legislative and regulatory activities like the Network Code on Demand Response, which defines the what on how our system is to be flexibilized, data interoperability implementing acts following Article 24 of the directive, the ongoing Data for Energy expert group that tackles that should pave the way on a stakeholder engagement and and identifies key gaps that we need to fill. And as this is also a very big group in the INSIEME project, we see our role into digesting these learnings and alignments and do deployments, prove and reality check these things and feedback to improve the legislation and the regulation. Next. So these are the 54 partners, as you can see, very big ones, Europe's biggest DSO, Enedis, or also Spanish Energy Association, and a big group of like Austrian companies, system operators, transmission system operator, distribution system operators, but also businesses that rely on the rich and reliable soil that the Austrian ecosystem provides, with 150,000 Austrians being part of at least one of the more than 12,000 energy communities. Very dynamic ecosystem here, but also players like Renault technology, Volvo technology that are building electric heavy-duty vehicles and are facing big challenges there. Italian DSO Areti, very well known in engineering and others. Next. We are covering 7 key use case areas: energy efficiency and flexibility management applications. So these classical energy savings applications that are currently chained to their home markets, and also applications that are based on price signals for grid fees, for energy tariffs. So they are. So there, we provide these applications a write once, run anywhere scenario, so that you can write them in one market and apply them in different markets. Same for collective self-consumption, meaning energy communities, energy sharing, in close conjunction with an implementation in the deployments for the things that come with the Citizen Energy Package that was published 3 weeks ago by the Commission. Then grid flexibility services, realization of flexible connection agreement infrastructures in Austria, in Spain, in France, in Italy, together with market-based balancing and local services, where we provide one European interface for market participants that want to engage in these flexibilization schemes. Electromobility, also, I've said that. Then renewables integration, mainly about forecasting for big wind farms and big PV installations, but also on the grid operator end. Networks and integration planning. There we are building on the work of Cuerva with the digital twins, and in Light AI mainly, who are providing smart deep reinforcement learning based grid management co-pilots for meshed transmission grids, but also they are applying these technologies to the low voltage end. And smart sector integration, what happens if we don't think just electricity, but also gas district heating and others, provide one common and streamlined data space for all these actors. Next. We said our aim is always to serve for a common API, meaning that for all the functionalities that energy communities, consultants, system operators have, they should be able to utilize one common interface at different levels. And for us, it should be as easy for service providers to provide solutions, a matter of minutes, 4 or 5 minutes, to build businesses on top of the possibilities of a participative energy system. And for active European customers, it should be as easy to utilize these possibilities, benefit from them, as if they would pay online via PayPal. Next. And our project really aims to tackle the key problem that there is a different degree and form of transposition in key European legislation. That means that we build regulation and legislation in Brussels, very good and visionary legislation, And then we see more and more that businesses try to utilize these possibilities at European scale, but they are not transposed in many member states, slowly transposed and very differently. And that is a thing that you can't credibly call an EU digital single market for energy, whilst allowing for principles like subsidiarity and realities, political realities. We see the seeds as an important means to an end to get to these things, to clarify responsibilities, to get to clear liabilities, and to provide the digital soil that it takes for European companies to emerge and make use of that very good and uh, and I think very ahead of the time vision that comes with the flexibilization of our systems, market-based flexibilities, bidirectional charging, and so on. And I think my 10 minutes are over now, so I would like to skip the rest of my slides so that the others have.
Okay, thank you very much, George. Anyways, the session is recorded, and also we will share with in the presentations of today. So you are welcome to check out the complete presentation of INSIEME. Thank you very much. And now we continue with the ODEON project presentation by Moises Anton. Moises, please.
Yes, thanks. So, as Raquel has introduced me, I'm Moises Anton. I'm the project coordinator of the ODEON project. In today's session, we'll be presenting how ODEON contributes mostly to this digital and green transition, which is part of the main goal of this workshop, focusing on how interoperability, data sharing, and scalable energy services play an important role in this change of paradigm. So next, please. So ODEON brings actually a strong consortium of partners all across Europe, combining mostly expertise from industry, research, and also counting with a lot of energy stakeholders. Next, please. Just for you to be aware of some introductory data about ODEON, we count with 35 partners across 13 different countries. And this project is being run during 4 years. And the main goal of our project is to develop and validating AI, IoT, and edge cloud solutions to support a more resilient and flexible energy system. We are validating all of these, these solutions through 5 pilot sites, ensuring that all the work that we do is not only theoretical, but also it's being deployed in real environments. Now, yes, next, please. So, as it was highlighted during this introduction for the workshop, the energy system is actually undergoing profound transformation, since we are moving from a centralized distributed systems. We are also moving from passive to active participation of the consumers and prosumers. And also we are seeing some changes across how we are moving from static infrastructure to a more data-driven system. This actually creates 3 major challenges highlighted in this slide, which is the scope also of ODEON, which is the expansion of the edge, counting with all our optimizations, all the distributed assets in the grid. Also the need for a great observability, meaning that we can have more data accesses from across the system, but also the need for coordination for different stakeholders in the energy value chain. So this actually plays a risk, as we see it, which is the fragmentation of the system. And this standing risk led us to actually play an important attention of how we solution and how all these systems involved can can communicate and can scale up to innovation. So next slide, Raquel, please. To address these challenges, mostly ODEON develops 5 key innovations that we take them as the key aspect to encourage the digital transformation. So first, we count with this Cloud Edge data platform that enables a reference implementation of data spaces. Secondly, we count with a catalog of AI artifacts, which allow machine learning to be deployed and orchestrated across the system. And thirdly, we also address different energy services for different actors, for distributed system operators, for aggregators and energy communities, enabling flexibility and autonomy of them, but also to prosumers, enabling an active participation of the energy markets. So the key idea is that all these services are built on shared data, interoperability, and AI-driven optimization. Next slide, please. I think you have to, yeah. One more time, okay. So yeah, no, the previous one, yeah. I wanted also to give you an overview of the ODEON architecture, since we work at different levels. So at the edge level, we work with the data generated coming from, as mentioned before, all the distributed energy sources and IoT devices connected through our IoT gateway. And this allows us actually to integrate all these systems while applying all at the same time data minimization principles, since we are getting a lot of data from different resources and we have to optimize this flow of data. The key idea is that this data is processed locally at the edge, which actually reduces this data transmission and improves the efficiency at the same time. And at the core of the system, as specified before, we come with the Cloud Edge infrastructure where this orchestration happens. Through this Cloud Edge orchestration and operation management, we coordinate all the data ops and AI ops through the entire continuum, which allow us to support different environments. For instance, these stakeholders that cannot host their own data space, the near edge environments, but also edge environments at the same time. So the idea is that on top of that, also we come with federated AI containers, which allow us at the same time to train, execute AI pipelines so that the continuum of this data is coordinated in a fruitful way. So the key value of this architecture is not only the data management, but enabling different data-driven energy services so that we can deliver for these modules, these innovations, correct orchestration data and AI artifacts that can deliver different services such as flexibility management, predictive maintenance, but also the optimization of the distributed assets. Next slide, please. So ODEON, as mentioned before, is validated in 5 pilot sites across Europe. Greece, Spain, Denmark, Ireland, and France are the places where we are holding our demonstration activities. So the key aspect of that is that we have a fruitful and detailed areas where we can ensure that our solutions are tested and they can be replicable or across the different countries in Europe. Next slide. So the idea is that within the lesson learned that we are actually, right now we are in the demonstration phase of the project, that all this data, all these results that we can gather from these demonstration sites can be, let's say, extrapolated to some lessons that we have been gathering across these few months. So we have highlighted here several aspects, but I just wanted to emphasize that Across these first phases of the project, we have identified some interoperability challenges, especially when integrating different heterogeneous systems in the demonstration sites. But also we have identified legacy integration as a challenge as well during these first months of the demonstration activities. But also not to forget how the regulatory fragmentation in the different countries is also playing some difficulties to have, let's say, more uniform European scenario, but we are targeting these different regulatory aspects across the countries as a way that how we can evolve to a more, let's say, uniform regulatory framework. And also how, and that's something that we are also identifying, how citizen engagement is really important to showcase our solutions and to not be losing them on the pathway towards this transformation. Next slide. So as part of the opportunities and synergies, how we can scale our project to, let's say, scale the impact, the collaboration across the project. So we are, and that's part of the today workshop as well, how we can build some synergies with other projects, learning from them, from HEDGE-IoT, our sister project, how they have been structuring the shared IoT infrastructure and the different edge infrastructure. From TwinEU, how we can learn from these digital twins and grid models and how it can be embedded also in our learnings. And from INSIEME, how this interoperability and data space standards can contribute to our projects. So with that, we hope to move from not isolated project and isolated pilot site, but learn from these scalable elements, and in order to build from ODEON a much better edge ecosystem, but also how we can improve the data space-based platform. Next slide. So I wanted just to say that this green and digital transition, that's the main goal of this workshop, cannot be achieved by isolated innovation. So it requires the help from interoperability, data sharing, and collaboration across other projects so that we can advance towards these challenges that were mentioned at the beginning of the presentation. So that's all on my end. Thank you.
Thank you very much, Moises, for the insightful presentation. So a reminder for the participants, you can submit your questions in the chat throughout the presentation, and we will address them during the panel discussion, so don't forget that. And next, we move to TwinEU project, presentation by Elias. Elias.
Thank you very much, Raquel. Thank you very much for the invitation for this event. I'm Elias Zafiropoulos, the technical manager of TwinEU, and I will present you the latest developments in the project. Next slide. Let's see a little bit the main elements of TwinEU project. TwinEU is a project that leverages a unique set of competencies coming from grid and market operators, technology providers, research centers to create a concept of a pan-European digital twin of the electricity grid. This pan-European digital twin is based on the federation of local twins that aim to enable a reliable, resilient, and safe operation of the electricity grid infrastructure while facilitating new business models that can accelerate the deployment of renewable energy sources across Europe. The project is delivered by a big consortium of approximately 75 partners. It has 8 pilots across Europe and is delivering 50 use cases. Next slide. In this slide, we briefly present the conceptual architecture of the project, the Digital Twin Federation, which includes the layer of local digital twins the layer of service orchestrator, the model sharing, the data sharing governance, and the data integration and homogenization. And also the services, the TwinEU services workbench that goes across cyber physical grid resilience, advanced observability and validation, forecasting, smart coordinated planning, and optimal grid control. And it provides access to several legacy systems, data hubs, data spaces, and multi-actor platforms. Next slide. Here we see briefly the 8 pilots that are dealing with several assets across Europe, extra high voltage down to low voltage and behind the meter, EV chargers, heat pumps, wind energy plants, HVDC links, and also there are several activities that cover the physical and the digital layer that has to do with forecasting, with demand side management, with asset management, capacity planning, flexibility management, and they involve several digital twin developments and cloud edge computing and machine learning activities. The 8 pilots are situated in Bulgaria, in the Eastern Mediterranean, Hungary, Slovenia, Italy, Netherlands, Germany, and the Iberia Peninsula, France. Next slide, please. So the project is now running its 3rd and final year, and we have, let's say, let's say, come up to specific challenges and opportunities during the first year, and also we are running now the pilots and the development of the technologies. I would like to share with you some challenges that have been identified through our, let's say, literature review, desktop research, and also dedicated interviews and interaction with all energy stakeholders and end users. Interoperability challenges, data silos create challenges to integrate the digital systems across different end users and stakeholders. We have identified a lack of the use of standardization, the use of standards, the lack of use of standards prevent a seamless communication and cooperation among players. We have identified the need to coordinate the system planning methodologies for distribution and transmission network. This has been, let's say, identified during the first years of the project. Currently, there are some activities that are going on and also reports and efforts for flexibility needs assessment, for coordinated system planning for TSOs and DSOs, and this is, let's say, ongoing activity. And also we have identified a not clear regulation for incentives, for investment incentives in digital technology. This is also, let's say, not helping very much into the integration of new, innovative, smart digital systems into the network. Next slide. Other barriers, opportunities, and aspirations of end users that have been identified is that all stakeholders require digital twins to be interoperable, modular, and federated. So, since several digital twins are developed across Europe, there is a need, there is an aspiration, a need for them to be interoperable, modular, and federated in order to be able to connect and valorize different benefits across the countries. And priority requirements that have been identified have been cybersecurity, has been standards for cross-border and cross-actor communication, alignment across national regulation for the EU energy policies, real-time system visibility, especially in the low voltage and medium voltage network that needs a strong investment in smart grid technology. And also strategic opportunities that appear is that digital twins that are developed can enable more flexibility, more renewables to be connected, and stronger TSO-DSO coordination on a common basis of the digital twins. And also there is a strong, as we said, the demand from stakeholders to have a federated and non-monolithic digital architectures. Next slide, please. Smart grid KPIs, smart grid performance indicators, is also a market expectation, reflecting also the interoperability metrics, cybersecurity resilience, and decarbonization progress. And also, these digital twin development initiatives should be favored by incentives-driven regulatory frameworks, promoting incentives for digital development and clear policy guidelines to stimulate these innovation activities and ensure robust cybersecurity practices. And of course, what we have identified is that there are many different approaches for digital twins. However, all these different approaches they share some common features, which is the physical layer of the assets, the virtual layer of their representation, and the data measurements, the services and the functionalities that the digital twins deliver, and connections and the interactions with previous elements. All these are now being developed, and we are trying to enforce them with standards, with interoperability, and also with a framework that can support the communication and the valorization across the energy stakeholders. Next slide, please. A few information about the pilot cases that are now running. They are practically local digital twins use cases that include cyber-physical grid resilience, digital twin developments in transmission distribution grid, power system training simulators, activities that have to do with the detection and mitigation of measurements tampering, false data injection, abnormal market participation detection, and protocol activation for mitigating risks and consequences. Also, we have use cases for grid monitoring and state space estimation. We have use cases for grid capacity map, technologies for market coupling with dynamic line rating technologies and co-optimized day ahead, intraday, and balancing market auctions. Fast frequency response service design with ex-ante system estimations, validated simulation, system defense plans, implementation scenarios, design and validation of medium voltage and high voltage assets, beam data models, and several other use cases. In total, 50 use cases. Next slide, please. Regarding now the federation, the federated infrastructure that is connecting all these local digital twin, this federation includes a big data and AI marketplace that can offer interoperable data sources and services for the energy stakeholders. It follows the EU data space standards for enhanced data governance and interoperability. And this federated infrastructure would be practically implemented and validated in real-world scenarios, connecting different end users through this federation in, let's say, high-level use cases that we name them pan-European scenarios, which is practically cross-pilot exercises, meaning that partners not initially involved in the pilots will be now connected through the federation and run some new scenarios, some new use cases that they can exchange data and models through the federation. The pan-EU scenarios that have been identified that are now running is a grid capacity map, connecting partners from Germany and the Iberian Peninsula, the market coupling with dynamic line rating, connecting partners from Hungary and Romania, single day ahead market coupling scenario, connecting Greece and Cyprus, security and stability scenarios, connecting Slovenian and Hungarian pilots. Next slide, please. Thank you very much for your attention. And I will be very happy to answer to any questions and discussion later on.
That was great, Elias. Thank you very much. And finally, we will hear from HEDGE-IoT, presented by Mihaylov. The floor is yours.
Thank you, Raquel. So I hope you can hear me. Hello, good morning. My name is Nikos Bilidis from European Dynamics. I'm the coordinator of HEDGE-IoT, and today I'm going to give a short presentation about the project in general, focusing also mainly on interoperability aspects that the project is introducing towards the digitalization of the power systems. Next slide, please. So first of all, some general details. So HEDGE-IoT answered to the call that deals with supporting the green and digital transformation of the energy ecosystem and enhancing its resilience through the development and piloting of AI, IoT, edge cloud platform solutions. The same call was answered also by ODEON, which is our sister project, and the project started in January of 2024, and it is going to run until June of 2027. Next slide, please. So HEDGE-IoT features a very extended consortium comprising 41 partners that cover the whole energy and ICT value chains. The interdisciplinarity of this consortium is vital in order to address the diverse and challenging goals of the call and also of in general, the European Commission. The consortium includes many European TSOs and DSOs, utilities, market operators, aggregators, energy asset manufacturers, IoT providers, a wide portfolio of end users, IT companies, AI experts, research and academia partners, experts on standardization and regulation, among others. Next slide, please. So let's have a look at the main objectives. So HEDGE-IoT proposes a novel digital framework which aims to deploy IoT assets at different levels of the energy system, starting from behind the meter and reaching up to the TSO level. It aims to add intelligence to the edge and cloud layers through advanced artificial intelligence and machine learning tools, and to bridge the cloud-edge continuum by introducing federated applications that are governed by advanced computational orchestration solutions. The HEDGE-IoT framework will upgrade the renewable hosting capacity of the energy systems. It will unleash a previously untapped flexibility potential, leveraging on IoT solutions, and it will increase the resilience of the grid towards the digitalization of the energy sector. It also aims to enable extended service and semantical and ontological interoperability and interconnectivity among distributed open platforms, systems, and edge devices through a decentralized data space compliant interoperability framework, and it facilitates the market uptake of the proposed solutions, contributing to the digitalization of Energy Action Plan. Next slide, please. So the HEDGE-IoT framework that we described before will be implemented, showcased, and validated in a set of 6 diverse large-scale field demonstrators, which take place in 6 European countries, which feature versatile geographic, climatic, regulatory, and social conditions. And as you can see, the pilots take place in Finland, in Greece, Italy, Netherlands, Portugal, and Slovenia, and cover a wide variety of use cases. Let's move on to the next slide. So diving into some more important first results, the project recently finalized its reference architecture, which is one of the most very important outcome, both from a technical and an interoperability perspective. The architecture provides a technology agnostic blueprint for how distributed digital energy systems can interoperate across the entire cloud edge continuum. And in practice, it creates a common framework that is capable of connecting IoT devices, edge nodes, cloud platforms, AI services, data spaces, energy applications in general, and external legacy systems under a unified interoperable ecosystem. It is structured, as you can see, in multiple layers. At the lower layer, we have the physical energy assets and the IoT infrastructure. Above that, HEDGE-IoT introduces edge and fog computing capabilities, where local intelligence can run closer to the field, enabling low latency processing, local observability, faster control decisions, and let's say more privacy-preserving operations. The next layer focuses on orchestration and interoperability. This is a key part of the framework through semantic interoperability mechanisms, standardized interfaces, APIs, and data space compliant data exchange services and data space connectors. Through all these, heterogeneous systems can communicate even when they use different technologies, vendors, or data models. This helps us to break data silos that currently exist and vendor lock-in. And it is particularly important in Europe's energy landscape, where fragmentation remains one of the biggest barriers to scalability. On top of this interoperable infrastructure, HEDGE-IoT supports advanced digital services such as artificial intelligence and machine learning applications for forecasting, flexibility management, federated learning, swarm intelligence, distributed optimization, and others. The important point is that these services are not tied to one specific platform or infrastructure. They can be deployed dynamically across edge or cloud environments, depending on operational requirements. They all reside in our App Store, which is also data space compliant and features connectivity through a data space connector, and their execution in most cases where the interrelevant is governed by our computational orchestration, which dynamically allocates the resources. Another important aspect is that the architecture was designed to be reusable and extensible. And although it is validated through the 6 pilots of the project, the architecture is not pilot specific. It can serve as a reference blueprint for future smart grids, smart building, flexibility markets, or energy community applications beyond the project. Finally, interoperability and standardization are at the core. By being compliant with data space principles, the new data space protocol, standards such as SAREV, the Common Information Model, and bridge recommendations that stem from bridge from other projects. We ensure that the solutions that are being developed can evolve into scalable and replicable European digital energy solutions. Let's go to the next slide. To strengthen the interoperability and alignment with the European energy ecosystem, the project has mapped the architecture that I showed before onto the Bridge Data Exchange Reference Architecture, the DIRA, and this is the result that you can see here. The DIRA, as you may know, provides a common European reference framework by describing how energy data is exchanged across systems, organizations, and services. And through this alignment with DIRA, we ensure that our architecture is not developed in isolation, but it follows a shared European approach. The mapping demonstrates that HEDGE-IoT covers all major functional dimensions of the DIRA model. At the infrastructure level, the project supports distributed fog, edge, and cloud computing resources. At the interoperability level, we have semantic models, APIs, ontologies, and data exchange mechanisms. From the governance and data space perspective, we integrate data space compliant, trusted data exchange mechanisms and connectors. And in general, all this is highly aligned with the objectives of the European Data Spaces Initiative and the Digitalization of Energy Action Plan. The mapping also highlights how the project supports higher level digital services. And so we try to prove that HEDGE-IoT is not only simply developing isolated technical components, we are building a modular and standards-aligned digital ecosystem. Next slide, please. I will close by connecting HEDGE-IoT with Europe's broader green and digital transition ambitions. From the beginning, the vision has been very clear to leverage IoT, AI, and interoperable digital technologies across the entire energy ecosystem. The reference architecture, the interoperable data space, the orchestration framework, the 6 pilots are all concrete building blocks towards that vision. HEDGE-IoT contributes to Europe's decarbonization goals by transforming IoT into a system-level capability. We are bridging the cloud-edge continuum through AI, federated learning, and distributed orchestration, which improves scalability and responsiveness. And we aim to make this transformation repeatable and trustworthy. We are aligning with open standards, with semantic interoperability approaches, and we contribute viable evidence towards European initiatives and policies such as the AI Act, the Data Act, which are all very relevant these days. In summary, we deliver more than individual tools or pilot applications. The project provides a reusable digital framework and an interoperable ecosystem, hoping that Europe can build upon to accelerate the grid and digital transformation. Thank you. Happy to answer any questions.
Thank you very much, Elias, for diving deep into your project. So, well, thank you very much for all the speakers for these very interesting presentations. Without doubt, today we have seen that we have large consortiums with common ground and also complementary strengths. So now let's open it up for discussion. So moderated by our colleague Vukasin from HEDGE-IoT. The floor is yours.
Thank you. Thank you, Raquel. So as Raquel said, let's now move to the panel discussion where we will explore some of the broader technical, regulatory, and societal questions linked to Europe's digitally powered green transition. Let's start with interoperability, which is a recurring challenge across all Horizon Europe digital energy projects. And the first question is, how can European digital energy projects ensure interoperability between IoT platforms, data spaces, digital twins, and AI-driven services in order to avoid the fragmented innovation ecosystems? So I would like to begin with ODEON. So Moises, do you want to start?
Okay, thanks. So yeah, actually from the ODEON perspective, we understand that interoperability needs to be actually built from the beginning of the project. That means that, and that's what we did also in ODEON, that all these, we need to align with all these existing European frameworks, standards, and reference architecture so that we can cover up the interoperability technical issues. But we also understand that interoperability can also be understood as not only technical, because data, for instance, needs to be understood in the same way across different systems, which at the end also requires this work and this alignment to existing methodologies and different data models, where these data governance frameworks can be extrapolated to the different projects. And also just to highlight that interoperability also is not built under the same project, but also among the collaboration with other projects, as we have been highlighting during these workshops. So sharing best practices, even working towards interoperable use cases across different projects. That's something that HEDGE-IoT and ODEON is taking a look, can be enhancing these interoperability aspects and move towards a truly interconnected system.
Thank you, Moises. Ilya, do you want to add something from the twin perspective?
Yes, I fully agree with what Moise mentioned. I would only like to add that it is important to include the end users in the development, meaning that once they are an important elements because they have the topic is very big. There are several issues and legacy systems that have to be taken under consideration, and several different services, functionalities, use cases, problems that occur. So if the end users are included, they can provide their field experience and their real needs. This is the one element. And also the developments are important to follow an agile approach of development, meaning consecutive rounds of improvement in order to fine tune in the end something that is really meaningful to be applied by the end users.
Thank you, Ilya. Nicholas, do you want to complement this from the HEDGE-IoT perspective?
Yes, thank you, Vuk. So basically, I totally agree with both Ilias and Moises. I see also, let's say, there are two pillars. There is the technical interoperability, there is the semantical interoperability. The first one, as Moises also mentioned, it's something that we need to work from the beginning of the projects. We need to to go into in very detail in the whole ecosystem, what has been done in previous projects, how we can build upon existing solutions and not create again new things, new platforms, new systems that are let's say not connected with what has been done in the past. For this, we need synergies, we need initiatives such as Bridge, such as AIoTI, and others. Also, the use cases repository of Bridge is something that can be very useful. And building on the existing effort now that we have towards common data spaces, a common energy data space, which also INSIEME is working towards, is very, very critical as it will provide common practices both on the technical side but also on the semantic side. So especially in the IoT domain, there are many, many different standards and protocols which create fragmentation. So we need to see how we can align so that many people, most of the people will use the same vocabulary, the same ontology, so that everybody can speak the same language. And finally, also based on what Ilya said, creating trust for the end users to adopt new practices that may, in some points, be out of what they're used to, is also very important and the key to bring everything forward and to scale up.
Thank you, Nikos. And last but not least, Georg, do you want to add something from INSIEME's perspective?
Yes. So on the data space, and I think our viewpoint is that we are not so much focused on the interoperability between innovation ecosystems, but on the data space, and we're nearing a point where the regulation clearly tells us what needs to be supported in many member states. If you look at the network code on demand response, if we look at different implementing regulations, they are bringing markets and real life settings into order. So what we do in INSIEME is we put forward the cooperation with IC, ETSI and Tenelec, engage with the industry that needs to support certain developments. So for example, when we do flexible connection agreements through our data space IoT platforms, we directly engage with outside partners, with the ones with home energy management system vendors, industrial energy management system vendors. We accept that the things and components that we build in an open source manner, that we build them as reference implementations to drive the standards. But at the end of the day, we are very much focused in driving the standards and not so much, and providing good reference implementations as well, but really that focus on standardized interfaces and accepting that what we build might be integrated in a different manner by others, puts interoperability first also, and that's the way that how we see it.
Thank you, Georg. So basically, it's clear that interoperability is sort of becoming a prerequisite for scalability and not just a technical feature. And now let's move on to the next question. This one is for ODEON project. So one challenge many projects face is moving from successful pilots into real operational environments. And the question is, what are the main technical and regulatory barriers that still prevent successful digital energy solutions from scaling beyond pilot environments into real operational energy systems? So, Moises, do you mind answering this one?
Yeah. So actually, the main regulatory barriers is that at least we can see that from different countries we encounter different codes, different laws, different ways to implement things, and that, as I mentioned during my presentation, we see that it could be a barrier that prevents implementation, the implementation of a successful, let's say, uniform solution, and that's something that we are currently encountering in our project. So what we can extract from that is that we can identify how these solutions in ODEON can be implemented in the different countries and what lessons learned we can have in terms of regulatory aspects, so that we can say that they are there and let's work towards on the basis of these different country-based aspects, how we can work toward a more unified, let's say, solution.
Thank you, Moses. And now let's move on to the next question, which talks about another important topic, which is long-term impact beyond the project lifetimes. And I think that this topic becomes more and more talked about from every year. And the question is, how can Horizon Europe projects collaborate more effectively to create reusable digital building blocks and the long-term impact beyond the lifetime of individual projects? So, Ilya, do you want to start with answering this question?
Yes, I believe there are several things that can be done, and of course, we can all discuss. And there are also a lot of things that are happening already. I would remind the Bridge Initiative, which is something that really provides a very good, let's say, environment to exchange ideas. One other thing that could be also support this activity is to include the Horizon Europe projects in the definition of the future topics, meaning that to have a well-defined process, a well-defined environment that the Horizon Europe projects that are finalizing can provide their ideas and their aspirations for the future research topics in a well-established, let's say, approach. I think this would also help in order to have a very good chain of activities that can really complement and follow after the and valorization also of the results.
Thank you, Ilya. Nikos, would you like to complement this?
Yes. So again, there are many dimensions here. One is to try to push the projects to create open source components, open source solutions, which are easily shareable with the community. This helps definitely to create more impact and allows other projects to build upon what has been started in previous projects. Definitely what Elias mentioned, to have collaboration spaces such as the Bridge Initiative and others. Also, a very useful, I think, tool which should be used and more by the project is the Horizon Results, the booster service, which helps the exploitation of the components that we are creating. And in general, maybe one thing that we could do from our side is many times we have to implement very complex solutions, too much technical work, and sometimes we place less emphasis on exploitation, on dissemination, which are very, very crucial activities and help us achieve to maximize impact. So we should never forget this, and we should try to place a lot of focus and work on transferring the results that we are creating towards the community.
Thank you, Nikos. And next question is to INSIEME project. And all four projects work extensively with energy data and often across highly heterogeneous stakeholders and infrastructures. So the question is, what is the biggest bottleneck you have encountered when accessing, sharing, or integrating energy data across multiple stakeholders, and how are you addressing it, and how are you combating this problem?
Yeah, thank you. So first of all, we always say that we are not so much focused on data sharing, but rather on data exchange in our projects, because we see data exchange and data sharing also as a means to an end. So there's a ton of critical processes that need to be realized in our sector for different things like organizing energy sharing, participating in markets, and one big bottleneck is the lack of regulatory clarity, because especially the regulated domain system operators, they play a big role in clearing up the dust, providing the digital infrastructure that it takes to for businesses to evolve. And in many ways, we're in a stage that this will take another year, 1.5 years, for the European level to come up with clear regulations, and that would then allow for the big diversity that we see in national data exchange infrastructures to become better and more streamlined. So clearly, what we do in Brussels at the moment is we write laws, we write requirements in 4 or 5 lines of legal text, and then we expect all the member states to do to solve these riddles that we give them at the European level in a similar manner, and then we end up in very diverse infrastructures. And here we need to think more in an end-to-end way. We should leave freedom and degrees of freedom in national implementations, but we should also give more streamlining and guidance and more emphasis on standardization. And how do we address that? This is through the interactions with the legal activities and the evolvement of the European legal framework, and with close interactions and cooperations with standards defining organizations.
Thank you, Georg, for answering this question. Next question is for HEDGE-IoT. So as energy systems become increasingly interconnected and digitalized, resilience becomes essential. How do we ensure that digitalization not only provides visibility, but also improves the physical and cyber resilience of the system?
Yes, so let's say that digitalization should not be limited only to monitoring and data collection. It should definitely enable the intelligent but also the secure system operation. Resilience should be at the core of the design phase. So it should be embedded directly into the architecture design, and let's say that in projects like HEDGE-IoT, resilience comes from combining real-time observability with AI-driven decision support, with federated approaches, with interoperable orchestration across the cloud edge continuum. And let's say digital resilience means to ensure that energy systems remain secure, adaptive, and operational under cyber threats, data disruptions, or rapidly changing grid conditions. So having all these interconnected systems in a seamless manner allows for more data to be circulated to reach the relevant actors. This can help to mitigate events before they even happen, because the actors have more information on their hands, so they can be proactive. And also with the application of concepts like the data spaces, they do not only focus on the exchange of data, but also provide a security dimension to how data are transmitted, exchanged, etc. Also, of course, we always need cybersecurity mechanisms to be applied to everything that we are building to ensure that the data are preserved, to preserve the data sovereignty, the data can be accessed only by actors who have the respective rights, etc., etc. So it's again 2 dimensions: how data are exchanged and how this provides more resilience to the grid when done in the correct manner.
Thank you, Nikos. We have 2 more questions. So the next question is for TwinEU and for INSIEME. So if you could ask the European Commission for one single concrete action to accelerate the digital green transition, what would it be? So, Ilya, do you want to start?
There are several things that can be done, and there are several things that are already being happening, and also there are ongoing activities. One thing that in our opinion, would help for the smart digitalization is to provide clear incentives of for all the end users of all the energy stakeholders to go forward with smart grid investments. To put it in, to provide a very well-defined and clear framework of the benefits that they will get once they go forward. And also in this direction, I think it is the activity of smart grid performance indicators, which is also something that is really going on and will provide this enabler, will be an enabler for defining the incentives to go for the smart digitalization of the energy sector.
Thank you, Ilya. Georg, I know that you have to leave, but if you have question, if you have time to answer this question, that would be great.
Sure. Yeah, thanks, Ilyas. I think from the viewpoint of Digital for Twin, that's a different angle, but super much supported, of course. On our end, where we build a data space more for the participative end of the energy system. I think what we need to learn is to go stage-wise. We are developing a data space, we are developing digital twins, we are developing AI and machine learning-based solutions based on the data that the data space provides. But from INSIEME side of things, we hear more and more the voices that say, why do we do another data project or data integration project? Why do we see in so many activities new energy community projects whilst we don't have a common understanding and a common implementation for what an energy community or collective energy consumption actually is? So what we should learn to do is to accept that for certain parts of that digital spine or the digital infrastructure that Svet mentioned in the beginning, we are in a stage where we have done enough research and where it's more time to apply instruments that are more focused on operationalization, which also means that we need to learn to target other actors. So if we see things as a pipeline, we should support businesses, maybe system operators as well, but they will come anyhow, instead of like doing a next university-driven project or a next research-driven project. Because what we need to learn is to operationalize the findings, draw a line, and then operationalize and institutionalize things, allow for the regulated domain to do and formulate clear responsibilities to them, support them, but get out of research mode and get into operationalization mode for certain things where we did enough research already.
Thank you, Georg. And one last question. So let's close with a forward-looking perspective. Let's imagine we are in 2030. What aspect of the European energy system will have changed radically thanks to the innovations you're developing today? So I would like to ask this question to Moises from ODEON.
Yeah, actually, by that year, there will be the continuation of the things we are actually looking and considering these 4 projects right now, because we'll see this shift from a centralized infrastructure driven to a more user-centric ecosystem. As well, we will be seeing this integration of millions of distributed assets that will have a participation in the system, and they will require this orchestration and this, let's say, management as well as part of a flexibility source. But equally also, this really great to highlight also this change in the role of the citizens, as we are progressively seeing during the past few years, moving towards these passive consumers to a much more active role of the participants. So the challenge overall is not technical per se, but also it's systemic. So it requires these both ends to consider as part of this evolution of the European energy system.
Thank you. Thank you, Moises. This closes today's panel discussion. And yeah, since we don't have any questions in the Q&A, I think we are ready to close this session. So thank you everybody for joining us today at the workshop called Towards a Digitally Powered Green Transition, Scaling Innovation and Connectivity in Energy Services. As a reminder, this session was organized by ODEON and HEDGE-IoT projects with the participation of INSIEME and TwinEU projects. I thank all speakers for their participation. And the recording of this session will be available on HEDGE-IoT and ODEON YouTube channels. We will publish it in the upcoming days. And yeah, stay tuned. Follow us on social media because we will definitely organize more events like this in the future.
Thank you very much.
Thank you very much.
all.
Bye bye.
Thank you.
Bye bye.
Thank you. Bye bye.
Bye.